4 decades, humans have risked everything to descend into Earth's deepest abyss, and what they've discovered there has forever changed our understanding of life and our planet. The story of human exploration in the Mariana Trench reads like science fiction. Tales of courageous pioneers descending into crushing darkness, technological marvels pushed to their absolute limits, and discoveries so profound they've rewritten textbooks. Yet every word of it is real, documented history of humanity's boldest venture into our planet's most hostile environment. Most people know we've sent humans to space and rovers to Mars, but few realize that exploring the deepest parts of our own oceans represents a far greater technological challenge. The engineering obstacles faced by deep-sea explorers exceed those encountered in space travel, yet their achievements receive a fraction of the recognition. What makes these exploration stories truly remarkable isn't just the technological triumph. It's the human courage required to descend into an environment so hostile that a single equipment failure would mean instant death. These expeditions represent humanity at its most adventurous, pushing into unknown territory with primitive equipment and sheer determination. Before we dive into these incredible expeditions, comment below and tell me where you're watching from and how the weather is treating you today. As you sit in comfort, remember that brave explorers have risked their lives descending 7 miles underwater to expand human knowledge. The journey we're exploring today spans over a century of human ingenuity, from the first crude attempts to measure ocean depths to sophisticated submersibles capable of reaching the deepest point on Earth. Each expedition built upon previous discoveries, gradually revealing the secrets of our planet's most mysterious realm. The earliest attempts to explore deep ocean regions began in the late 1800s with simple but ingenious methods. Naval expeditions used weighted ropes and sounding lines to measure depths, but these primitive techniques could only provide basic information about the seafloor's location, not its nature. The HMS Challenger expedition of 1872 to 1876 represented the first systematic attempt to study deep ocean environments. Using hemp rope weighted with cannonballs, they successfully measured depths exceeding 26,000 feet in various ocean basins, providing the first scientific evidence that enormous depths existed beneath the waves. These early depth measurements required tremendous patience and physical effort. Lowering and retrieving miles of rope took hours, and the measurements were often inaccurate due to ocean currents that caused the weighted lines to drift from vertical positions. Despite their limitations, these pioneering efforts established that the ocean contained features far more dramatic than the surface world. The discovery of such extreme depths sparked scientific curiosity about what might exist in these unreachable environments. The development of sonar technology during World War II revolutionized deep-sea exploration. Echo-sounding devices could map ocean floor topography with unprecedented accuracy, revealing the true scale and complexity of underwater mountain ranges, canyons, and trenches. In 1951, the British survey ship HMS Challenger 2 used advanced echo-sounding equipment to discover and measure Challenger Deep, the deepest point in the Mariana Trench. Their measurements revealed depths of approximately 37,000 feet, establishing this location as the deepest known point on Earth's surface. This discovery captured public imagination and scientific attention, creating pressure to develop technologies capable of reaching and exploring these extreme depths. The challenge was enormous, designing equipment that could withstand pressures over 1,000 times greater than sea level while maintaining life support systems for human occupants. First successful human descent to extreme ocean depths occurred in 1960, when Swiss oceanographer Jacques Piccard and US Navy Lieutenant Don Walsh descended to Challenger Deep in the bathyscaphe Trieste. This achievement represented one of humanity's greatest exploration milestones, comparable to the first human space flights. The Trieste consisted of a steel pressure sphere suspended beneath a large float filled with gasoline for buoyancy. The descent took nearly 5 hours, with the crew monitoring systems and making observations as they descended through layers of the ocean never before visited by humans. At maximum depth, their porthole revealed a cloud of sediment disturbed by their landing, but through the murk, they reported seeing what appeared to be a flatfish, the first evidence that complex life could survive in the deepest parts of our oceans. The psychological challenges of this descent were as significant as the technical ones. Enclosed in a steel sphere barely large enough for 2 people, Piccard and Walsh descended into absolute darkness, knowing that any structural failure would result in instant death from crushing pressure. Their successful return to the surface proved that human exploration of the deepest ocean was possible, though the primitive technology of the time limited their ability to conduct detailed scientific observations or collect samples. What aspect of these early explorations intrigues you most? The courage required, the primitive technology, or perhaps the groundbreaking discoveries? Share your thoughts in the comments below and I'll research it for a future episode. 4 decades after the Trieste dive, technological limitations prevented further human visits to the deepest trenches. The extreme engineering challenges and enormous costs made such expeditions rare, leaving the deepest ocean largely unexplored despite the proven ability to reach it. The development of remotely operated vehicles, ROVs, in the 1970s and 1980s provided new opportunities for deep-sea exploration without risking human lives. These robotic systems could remain underwater for extended periods, collecting samples and recording detailed observations impossible during brief human visits. Early ROVs were crewed by modern standards, connected to surface ships by miles of cable that transmitted power and control signals. Despite their limitations, these systems returned the first detailed images of deep-sea life and geological features, revealing ecosystems more complex and diverse than anyone had imagined. The discovery of hydrothermal vents in 1977 revolutionized understanding of deep-sea environments. ROV exploration revealed entire ecosystems based on chemosynthesis rather than photosynthesis, fundamentally changing concepts about where and how life could exist on Earth. These discoveries demonstrated the value of sustained deep-sea exploration using robotic systems, leading to increasingly sophisticated ROV designs capable of operating in the most extreme underwater environments. The next major milestone in human deep-sea exploration occurred in 2012, when filmmaker James Cameron made a solo descent to Challenger Deep in the purpose-built submersible Deep-Sea Challenger. This expedition represented the first human return to the deepest point on Earth in over 50 years. Cameron's submersible incorporated revolutionary technologies unavailable to earlier expeditions. High-definition cameras, advanced lighting systems, and sophisticated sample collection devices allowed unprecedented documentation of the deep-sea environment. The vertical design of Deep-Sea Challenger enabled rapid descent and ascent, maximizing time available for observation and sample collection at maximum depth. Advanced materials and engineering techniques created a vehicle far more capable than previous deep-sea exploration systems. Cameron's footage revealed a landscape more alien and beautiful than previous expeditions had been able to document. The high-definition images showed geological features, microbial communities, and environmental conditions in detail never before achieved at such depths. However, the brief duration of the visit, less than 3 hours at maximum depth, highlighted the continuing limitations of human-occupied deep-sea vehicles. The extreme conditions and engineering constraints still limited the scope of scientific activities possible during human visits. Modern deep-sea exploration relies increasingly on sophisticated robotic systems that can operate continuously for months in the extreme conditions of deep trenches. Autonomous underwater vehicles, AUVs, can conduct mapping and sampling operations without direct human control. Recent expeditions have used multiple coordinated vehicles to conduct comprehensive surveys of trench environments. Advanced sonar systems create detailed 3-dimensional maps, while specialized sampling devices collect specimens and environmental data. Like these stories of human courage and technological achievement? Hit that subscribe button and turn on notifications. Your support helps Ancient Underwater Mysteries continue exploring these incredible exploration stories. Your subscription means everything as we document humanity's greatest adventures. The development of advanced materials science has enabled construction of vehicles capable of withstanding the extreme conditions of deep trenches while housing sophisticated scientific instruments. Modern submersibles can collect samples, conduct experiments, and transmit real-time data to surface research teams. Fiber optic communication systems allow near-instantaneous transmission of data and imagery from the deepest parts of the ocean, enabling real-time scientific collaboration between surface researchers and deep-sea operations. Recent technological advances have made deep-sea exploration more accessible and cost-effective. Multiple research institutions now operate deep-sea vehicles, dramatically increasing the frequency and scope of deep ocean research expeditions. Scientific discoveries resulting from these explorations continue to surprise researchers. New species are discovered on nearly every deep-sea expedition, while geological and chemical observations provide insights into fundamental planetary processes. Some of the most significant recent discoveries include evidence of active microbial communities in deep-sea sediments, complex food webs based entirely on chemosynthesis, and geological processes that influence global climate patterns. International cooperation has become essential for deep-sea exploration, as no single nation has the resources to comprehensively study the world's deepest ocean regions. Collaborative expeditions combine expertise and equipment from multiple countries to achieve scientific goals impossible for individual institutions. The data collected from deep-sea explorations is shared globally, contributing to scientific understanding that benefits all humanity. These collaborative efforts demonstrate how exploration can unite nations in pursuit of knowledge about our shared planet. Future deep-sea exploration will likely rely on networks of autonomous vehicles capable of operating continuously in deep-sea environments. Advanced artificial intelligence systems will enable these vehicles to make independent decisions about sampling and data collection. The development of underwater habitats may eventually allow extended human presence in deep-sea environments, enabling more detailed scientific studies and technological development in these extreme conditions. What part of these exploration stories fascinates you most? The early courage of pioneers like Piccard and Walsh, the technological marvels of modern submersibles, or perhaps the ongoing discoveries? Comment below and share which aspect of deep-sea exploration you find most compelling. The legacy of deep-sea exploration extends far beyond scientific knowledge. The technologies developed for extreme underwater environments have found applications in space exploration, medical devices, and materials science. The courage and determination demonstrated by deep-sea explorers continues to inspire new generations of scientists and engineers. These expeditions prove that human curiosity and ingenuity can overcome seemingly impossible challenges. Every successful deep-sea expedition expands the boundaries of human experience and knowledge. The images, samples, and data collected from the deepest parts of our oceans contribute to understanding fundamental questions about life, geology, and planetary processes. The story of human exploration in the Mariana Trench represents humanity at its best, combining technological innovation, scientific curiosity, and personal courage to explore the unknown. These expeditions remind us that our planet still holds mysteries waiting to be discovered by those brave enough to seek them. As exploration technologies continue advancing, the deepest parts of our oceans will gradually reveal their secrets. Each new expedition builds upon the courage and achievements of earlier explorers, continuing a tradition of discovery that expands human knowledge and inspires future generations to push beyond known boundaries. The exploration of the Mariana Trench stands as proof that no challenge is too great for human ingenuity and determination. From primitive rope soundings to sophisticated robotic systems, each advance in deep-sea exploration capability represents a triumph of human creativity over seemingly insurmountable obstacles.